Assalamualaikum warahmatullahi wabarakatuh. Today we go to another hypothesis test, which is ANOVA. ANOVA is another inference statistic test. There are so many techniques in ANOVA. So one way ANOVA with an equal sample size, one way ANOVA with an equal sample size, and two way ANOVA. However, for this class, we only cover equal simple size. One way ANOVA with equal simple size. So ANOVA is method for testing an equality for three or more population names for analyzing sample variance. So actually they compare between a group of data. So the purpose of ANOVA is to test the significant difference between means, and implementing concept provide the brief introduction to the basics of statistics significant test. Okay. So this is one way ANOVA with equal simple size. So we assume the population have a normal standard deviation, same variance or standard deviations, and the sample are randoms and independent each other. So this is a notation for ANOVA. N is size of each sample, K is number of population, S is variant sample mean, S square P is populated variance obtained by calculating the mean sample variance. So this is the F test, which is a statistic test for the ANOVA. Formula is the variance between sample and variance within sample. So this is the formula. So the variance with sample between sample called is variance due to the treatment. So this is the sample. So this is the data. So this is the variance between sample. Okay, estimate the common population variance that is based on the variety among the sample mean. So variety between sample, let's say we have two sample in here. So we have data for the group A and group B. The variance between sample is the variance between group A and also a group B. It's called a variance due to error. The estimation of the common population variance based on the sample variance. So the critical value F, we need to know about nominator degree of freedom K minus 1. Denominator degree of freedom K n minus 1. K is number of populations, n is sample size. So this example 1, the list of head injured by the car crash test dummy for the 4 different types of car. So we use the significant test 0.05 to test the non-hypothesis that the different types of car have the same meaning. So that means we have 4 group in here: subcompact car, second group is compact car, third group is mid-size car, and full-size car is a fourth group. So the hypothesis says to test that the different types of car have the same mean. Okay, this is the data. So now we define the hypothesis. The null hypothesis, we assume that's all data. This is data 1, 2, and 3, and 4 has the equal means. Okay, the H1 represent at least one mean is difference. Okay, and then for each category we find the n, the means, and also the standard deviation. So for example, category 1 is subcompact, the n, the median, and also the standard deviation. Similar with category 2, the n, the mean, and also the standard deviation. And then category 3 similar, means number of record, mean, and also standard deviation. So similar with category 4, we calculate the n, the mean, and also the standard deviation. So and then the next step, we find the variance between sample. This is the mean between sample and also the standard deviation between sample. And then find the variance between samples. So this is the formula. The n as quarter 2 power by 2 and x. This is the okay. Okay, the 5 is as standard deviation. This one is standard deviation times n times 2. Okay, so you get this, and then you find a variance between the sample. The previous one is between the samples. This one is within the sample. So this is the formula, and then calculate the F statistic test with the variance between the sample and also the variance within the sample. So divide by this, you can got 0.992. So and then calculate the numerator and denominator degree. So numerator in here is 3 and denominator is 16. And then find the critical value at the significant test 0.05 for the by using F distributed table. So you get the critical value. The critical value of F is 3.2389. So and then claim the hypothesis and state the conclusion, because since F test less than F critical value 0.99 is less than 3.2, so conclusion, we fail to reject the null hypothesis. Okay, fail to reject the null hypothesis. This is a sufficient evidence to claim that the different types of car have the same mean for the head engine. Okay. And then goes to example 2 is chess. The list of chess declaration on the car crash test dummy for 4 different types of car. Use the 0.05 significant level to test the null hypothesis. So the hypothesis that the different types of car have the same means. Okay. This is example of data. They put the means and also the standard deviation. So the hypothesis is we assume all groups of car have the same means. So H1 is at least one mean is different. So step 2, we already give the value for the X and also for the standard deviation, for the mean and standard deviation. So now we just need to calculate the variance between sample. Okay, this is the mean, this is standard deviation. Okay, and then find the variance sample. Okay, this is the formula. And then find the variance within sample. So this one, and then calculate F by using this formula, and then we get F 1.34. So calculate numerator and denominator. In this case, we got 3 and also 16. And find the critical test F for the significant test 0.05 from the F distributed graph. You get F, the critical value 3.2389. So this is the claim. Okay, because the value for F test statistic less than F critical value, so we fail to reject, okay, of the null hypothesis. So this is evidence, sufficient evidence to claim that the different types of car have the same means for the chess declarations. Okay, and then this is your exercise, and please submit in the e-learning. Okay, hopefully you can submit by today. So we will explain the answer, discuss the answer next class. Okay, so this is the data. Okay, thank you. See you tomorrow.